Today we're going to be talking about improper fractions. For the last few weeks we've been talking about fractions, and they're just regular fractions, the ones we're used to seeing, and we just call them proper fractions. So an improper fraction is actually one where the numerator is the bigger number or it's exactly the same as the denominator. We're used to seeing it where the numerator is always smaller and the denominator is always bigger. But now we're going to see it'll look a little differently. So by definition, an improper fraction is a fraction where the numerator is either bigger or equal to the denominator. So what this could look like, we're used to seeing like 1/4. This is a proper fraction. An improper fraction would be one where the numerator is bigger than the denominator or equal to it. So it could be 5/4 or even 4/4, which of course equals 1, right? So whenever you see a fraction where the number is bigger than the denominator or the number is equal to the denominator, these are examples of improper fractions. So let's look at another improper fraction. Let's say we had the improper fraction 9/2. So I have drawn some circles, and I want you to do the same exact thing, but I want you to do it on the student side, and I want you to color in 9 of those halves. That would be 2 halves, 4 halves, 6 halves, 8 halves, and then we would need 9 halves, so we would only color in this last one on this side. So right here you have 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, and 9 halves. Because we're only counting the number of pieces, and all the pieces have been cut into halves. So we don't just say, oh, there's 9 ninths, because these weren't cut into ninths, they were cut into halves. So the denominator, we're only going to look at how it was cut, and the numerator now, we're going to look at the actual pieces shaded in. So improper fractions are used when we have more than just one whole. This is when we're going to see 2 wholes being used, 3 wholes, and so on and so forth. So that's an example of what an improper fraction would look like and how it would be modeled with fraction circles. I can clearly see that there are 4 whole pieces and then a half piece left over. So this is an improper fraction, and we're going to be working today on turning it into this, which is called a mixed number. It's called a mixed number because it's mixed between whole numbers and fractions. And I'll show you an actual method for that in just a second. Now, I'm going to show you how to actually do a quick way to make an improper fraction a mixed number. So we're going to be turning improper fractions into mixed numbers. In our other video, we'll be doing the opposite. We'll be turning mixed numbers into improper, because like I said, in math, we use the improper fractions because they're easier to work with. We see the mixed numbers in the real world. It's more common to see a mixed number than an improper fraction. Okay, so let's take that fraction we had, 9 halves, and I'm going to show you something we call the ice cream cone method. We're going to stick a big circle around the numerator, and then we have a cone around the denominator. Do you see the ice cream cone? The ice cream scoop, we want it to be bigger than the actual cone because that's the good part of the ice cream, right? Well, when you're doing improper fractions into mixed numbers, you're going to be using division. You're going to see how many times the denominator will go into the numerator, because I told you many times before that a fraction is just a division problem. Okay, so how this works, how the actual method works, the ice cream cone method, when you get into the habit of this, you won't have to call it the ice cream cone method. You can actually get to a point where you don't have to draw the ice cream cones. But what you're going to do is you're going to think ice cream has to be kept in the freezer. So in division, we'll call this little guy, even though this is our division sign, we're going to call it the freezer. So we're going to put 9 inside it because it's the ice cream part. And we usually keep our cones outside the freezer. I don't think anybody puts them in the freezer. You may, I don't know, but I know that we keep them in our pantry or in our cabinets. So the 2 is going to go on the outside. So my goal is to see how many times 2 is going to go into 9. I have to go to another page, but you're still writing on your student side. On your teacher side, I apologize. So we have the 2 9ths, and I'm going to put the ice cream cone back over here so you can see. So 2 is the ice cream cone. It goes outside the freezer. Here's the freezer. The ice cream's inside it, okay? Now, I know that 2 times 4 is 8. When I subtract, I have 1 left over. I'm going to be reporting all remainders as fractions. So it went in 4 whole times. So that's my big number. There was 1 left over, and they were cut up into halves. So 9 halves does equal 4 1/2. When you're writing these down, you always start at the whole pieces, and you circle around until you end up here. So you write down the 4 as the whole pieces. This is your numerator, and the denominator is what you divide it by. So it's always going to be a clockwise motion. Let's try another one real quick. Let's say we have 15 eighths. So we're going to draw our ice cream cone. This will be in the freezer. This will be out of the freezer. So I know that 15 goes inside, 8's over here. 8 times 1 is 8, obviously. 8 times 2 is 16. So this isn't going to go in but 1 time. So 8 times 1 is 8. I subtract and I get 7. So I have 7 left over. I'm going to report it as a fraction. I'm going to go in clockwise motion. So 8 went in there 1 whole time with 7 left over, and they were cut into 8 pieces. So 1 7/8 is my mixed number. It's just a division problem, and then when you're writing it down, you start with the whole number, the numerator, and the denominator. I remember denominator, divide, they both start with a D. Something else we may run into when we are doing these improper fractions is that we may get the fractional remainder where it's not in simplest form. So you always have to try to get your remainder that you report as a fraction in simplest form. That's why we learned simplest form before we started this. So let's say we had 18 fourths. Okay? Let's get our ice cream cone going on. 18 goes in the freezer, 4 on the outside. 4 goes into 18 4 times. 4 times 4 is 16. I subtract and I have 2 left over. So I do my clockwise motion with my whole number going around to my numerator and denominator. It went in there 4 whole times, 2 left over out of the 4 pieces it was cut into. Now 2 fourths can be reduced because they are both even. So I'm going to divide by 2. And so really 4 2 fourths is 4 1/2. So improper fractions, when you turn them into mixed numbers, sometimes you're going to have to reduce to simplest form. So watch out for that. And we talked about why it's important to have simplest form, because it's just simpler to work with. We want to get fractions down as low as they can go, even though they still represent the same piece, so they're just easier to work with.